Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Athirah Binti Ahmad Rohaizad from DGU 5A and my matric number is 01 DGU 20F1010. Today I would like to present about matrices and variance, covariance propagation, DCG 509-50192 survey adjustment. Next, I would like to present about the meaning of matrices and variance covariance propagation. Okay, this is the agenda in this presentation. Title: Describe the matrices and variance covariance propagation. Solve the question. Show the step of the equation solution, outcome, and lastly, close conclusion. Okay, this is the meaning of matrices, variance, covariance, propagation. First, the meaning of matrix. Matrix is a plural form of a matrix, which is a rectangle array of or a table where numbers or elements are arranged in row and columns. Okay, they can have any number of columns and rows. Different operations can be performed on matrix, such as addition, column multiplication, and transposition. Okay, next, variance. The range of a data set's value around its mean is referred to as variance. It is derived by averaging the probability connected to each of the square deviations from the expected value. As variance rises, the distance between the set's number and the mean widens. Okay, lastly, the meaning of covariance propagation. Yeah, it's crucial to know how precise these estimate or computed numbers are when using measurements to find the best estimate of unknown quantities in this square problem, which is together with accompanying estimates of variance and covariance. Okay, to do this, it is necessary to comprehend variance propagation so that specific instruction and strategies can be created. Okay, then next, solve the question 1. Okay, when computing the latitude and departure of a line, the following well-known equations are used. Latitude equal d cos azimuth, departure equal d sin azimuth, where lat is latitude, that is departure, az is the azimuth, and d is the horizontal leg of the line. To derive the estimate error in the line's latitude and departure, the following partial derivatives are required in using equation. Partial derivative lat partial derivative d equal cos azimuth, partial derivative dat partial derivative d equals sin az. Next, partial derivative lat partial derivative az equal minus d sin az. Partial derivative dat partial derivative az equal minus d cos az. From the above statement, questions as below. A transverse course has a leg of and an azimuth of. What are the latitude and departure and their estimate error? Okay, we get the leg equal 456.87 plus minus 0.02 meter. For the azimuth equal 23 degree, 35 minute and 26 second plus minus 9 second. Okay, lat equal d cos azimuth and dat equal d sin az. Okay, for the first step is derivative of lat with respect to d. Partial derivative lat per partial derivative d equal cos azimuth. For the cos is 23 degree, 35 minute and 26 second. The answer is 0.916428 709. Okay, for the derivative of light with respect to azimuth is partial derivative light per partial derivative d equal, for the formula is minus d sine azimuth equal minus 456.87 sine 20 degree, 23 degree, 35 minute and 26 second. And the answer is 182.8384. The next step is derivative of that with respect to d. Partial derivative that per partial derivative d equals sine azimuth. The answer for sine is sine 23 degree, 35 minute and 36 second, and we get the answer is 0.9400197977. And for the derivative of that with respect to azimuth, we get the partial derivative that per partial derivative azimuth equal minus d cos azimuth. And for the answer is minus 456.87 cos 23 degree, 35 minute, 26 second, and we get the answer is minus 418.6887. Okay, this is the last step. To get the answer for questions 1. Okay, substitute into nonlinear equation. Okay, as substitute, let equal square root partial derivative lab per partial derivative d multiply as d square 2 plus partial derivative that per partial derivative az let multiply as azimuth square 2. Okay, for the answer is square root 0.916428.709 square 2 plus minus 182.8384 multiply 9 second multiply pi per 180 square 2. And for the answer, square root is 0.183984123, and the answer is 0.91642. Okay, and the last step is substitute that equal square root partial derivative that per partial derivative d multiply as d square 2 plus partial derivative that per partial derivative az multiply as azimuth square 2, and we get for the answer square root 0.400197977 square 2 plus minus 418.6887 multiply 9 second multiply pi per 180 square 2, and the answer for square root is 0.160492.167, and the last answer is 0.4009006. Okay, this is the outcome for questions number 1. Okay, next I would like to present the questions 2. A total station instrument has a vertical compensator accurate to within plus minus 0.3 second, a digital reading accuracy of plus minus 5 second, and a distance measuring accuracy of plus minus 5 mm plus 5 ppm. The initial slope distance was 1256.78 meter. The instrument was set to within plus minus 0.005 meter of the station, and the target was set to within plus minus 0.01 meter. The instrument's height was 5.10 plus minus 0.01 meter, and the prism height was 6.78 plus minus 0.01 meter. The zenith angle was measured in only one position and was recorded as 88 degree, 13 degree, 13 minute, and 15 seconds. What are the correct elevation difference and estimate error? The following well-known equations are used using CR equal 0.0675. The increment H equal HI plus S cosec plus CR and sin Z per 1000 1000 to minus HR. Increment H equal 5.12 plus 1256.78 cos 88 degree, 13 minutes, 15 second plus 0.0675 plus multiply 1256.078 since 88 degree, 13 minutes, 15 seconds, square 2 minus 6.078. The answer is 37.466. Okay, for the equation for digital picture of the light and total station, the estimate error for single observation is partial derivation equal square root 2 derivative square 2 plus derivative square 2, and the answer is plus minus 7.1 second. The next step is convert 5 mm to 0.1064 feet. Then estimate the area distance equals square root 0.005 square 2 plus 0.01 square 2 plus 0.0164 square 2 plus 5 multiply 10 and 1256.76 per 100,000 square 2, and we get the answer is plus minus 0.021 feet. Okay, the total error in the trigonometric leveling is equal square root 0.01 square 2 plus 0.01 square 2 plus 0.031 multiply 0.021 square 2 plus minus bracket minus 1256.172 bracket 7.1 second per piece bracket, and we get the answer, and the answer is plus minus 0.045 feet. Okay, that's all for the step for questions 2. Okay, the conclusion is in this topic is we know the meaning of matrix, variance, and covariance propagation. Okay, next we know the step how to calculate latitude and depth, and also how to get the estimate error in this question. Okay, that's all from me. Thank you.